All right, everyone, here we go. Number 2, solving log equations. This one will be a little bit faster. Again, I gave you guys a little notes outline to possibly help you kind of go through this one. So I'm just going to start with what a log equation or logarithmic equation. I just write the word log. I don't like writing long pieces of things. So of words because it just takes too long. Log base 36 of e equals to the 1/2. So you guys did, I believe, on the first day, you rewrote these things. So I'm just going to jump into it. You need to rewrite this where we're switching, catching it. We're switching the x and the y. So now we get 36 to the 1/2 equals x. We've just got to decide what this means. Don't know if you guys have done it before, so I'm going to tackle it and go from there. This is a radical written in fractional exponent form. So we rewrite this as this is always inside, this is the power, and this is always the root. So we rewrite this with a house. The house gets the power. The root goes inside here. 36 goes in here equals x. Now we're asking ourselves, what is the square root of 36 to the first power? Well, it's 6 to the first power, x equals 6. So we're happy, okay? So this is where you guys are going to use, I think it was, you called it in the book, it calls it the inverse definition or something like that. So we're just using inverses to find our answer. So let me look at another example for you guys here. It gets, I don't think it gets too crazy for you guys. Let me look. Let's just do number 8. So this is number 8, guys. Number 8, log of 27x equals 3/4 power. Just making sure you guys are kind of okay with the skills that you need. Okay, so we're going to flip this, all right? And so we're going to get 27 to the 3/4 power equals x. Now from there, this is the radical, this is the power. Probably too small for you to see, but I don't know, you got better eyes than I do. So, radical, power. Number goes in here. Don't know if you can use the calculators in class. Here's what we're dealing with. And I messed that up. Flip that over, because this will never work. Okay, this is 4. This is 3. Let's do 4 and 3. Make changes right in the middle of it. 4 and 3. And those of you that wrote in pen are like, oh my gosh, why do you have to do that? Because I messed up. All right, so here we go. Root 3 of 27. In other words, what multiplies 3 times to make 27? Well, 3 does. 3 times 3 is 9, times 3 is 27. So therefore, I get 3 as an answer to just this. Okay? I don't think this is number 8. So erase number 8, because I think I messed up on that one. Yes, I messed up on that one. This is not number 8. It's like number 8. Okay? So 3 to the 4th power equals x. Now, what's 3 times 3 times 3 times 3? It's going to be 81 equals x. That's my answer. Okay? So that's how you solve the basic log equations. All right, now, of course they can't go, oh, these are so nice, everything's so pretty. Why can't we all stay in Never Never Land and not do anything hard? That's because it's impossible to do that. So here we go. Hey, Sheldon, you're on video. Yeah, I'm doing this for Penn, Miss Penn. So, yeah, all right. So, give me about 5 minutes, I'll be done. I lied. I'm like a pastor at church. I say 5 minutes, that may mean 30. All right, here we go. So, let's look at, oh geez, guys. Kind of working quickly at the last minute here. Well, let's just do the one. All right. So log 4. Make sure I get this one right so I don't screw you guys up. Log 4 of x squared. Log 4 of x squared equals log 4 of, got to make sure this is right, log 4 of negative 6x minus 8. So, all right, now you're like, what the heck's going on? I got a log on this side, I got a log on this side, I got an x squared here. Okay, so there's something called the one-to-one rule pretty much across the board. In other words, let's say I've got 2x equals 2. What happens to the 2's? Well, we divide them out, right? We divide them out like this. They cancel and I get 1. Really what we're saying is that it's the one, these two are the same, so they cancel each other out, and I'm left with whatever's left there, okay? And there's always an imaginary one that we're multiplying by. So when we have a one-to-one situation like this, x equals the square root of 2. I have the same exact thing on either side. So if I squared both sides, what happens? Well, I end up getting an x equals 2 because the square roots. The one-to-one makes those things cancel out, and that's my answer. So, looking at this, you're like, well, how the heck do I get this stuff out of the way? Well, we have a one-to-one situation. This is the same as this. There's a whole different explanation on why it cancels, but they cancel out of the way, and I'm left with, hopefully, this is an equal sign, guys, sorry. Going too fast trying to get done so I can actually plan my classes. There we go. That's what we're dealing with. Now, I know you guys did a little review on quadratics. It was actually kind of perfect. Then what do? We slide over. We slide over. And make everything go to the left side. Since it's a negative 6, it's going to be a positive 6x over here. So I got x squared plus 6x. Then I've got to move the 8 over there. I get plus 8, and I'm left with 0. So then at that point, we've got to deal with this. So it's like, okay, I don't know. There's like this method and this method. And then there's this method where you like go all over the place to factor. And then there's this method to factor. And there's like 40 million ways to factor. I don't know how you like to factor. I don't care how you like to factor. But I do know you need to know how to factor. So I'm just going to do what's called the guess and check method. What multiplies to make 8 but adds to make 6? My two parentheses. I do know that 4 plus 2 makes 6. If I do 4 times 2, it makes 8. So therefore I have 4 plus 2 equals 0. I use what's called the zero product property. Those of you that are moving on, this right here from here down is probably one of the most important things you'll ever do. Factoring, setting it equal to 0. X plus 4 equals 0. X equals negative 4. X plus 2 equals 0. X equals negative 2. So, all you have to do now is, these are the solutions, but they may not be real solutions. If you plug any one of these back into the equation and you get a negative inside here, if you get a negative inside here, it won't work, okay? So if I plug negative 2 in, negative 2 squared is 4, I'm good. If I plug negative 2 in here, negative 4 times negative 12, negative 2 times negative 6 is 12. 12 minus 8 is 4. Positive 4, I'm good, okay? So you have to plug these back in to make sure that they have the correct solutions. If it comes out as a negative, it is not a solution, okay? Even though it gives you a solution. Those are called extraneous solutions. Again, I don't know where you guys have been, so I'm trying to cover all the bases that they may throw at you. Here's the reason why. Let's just talk about real quick about a basic logarithmic equation. A basic logarithmic equation has a graph that looks like this. right? 1 and 0, 1 in the base, or the base and 1, and I have this dotted line. This says that my domain is anything over here, domain. That means these are the only numbers that can work, right? That means anything in here has to be positive. This is bad. So when you plug an answer back into here, inside of this has to be positive based on the domain. You always have to protect your domain, okay? Always. That's why some things are not solutions. All right, guys, that's your one-to-one. You use your inverse rule on the other ones. I'm available during 5th. If you want to walk over, I have calculus. We're doing a bunch of review, but I'll gladly help you guys out. Come by at lunch, whatever you need. Just remember, in this, you have some old skills. You have to deal with fractional exponents, and you have to factor a lot. Okay? So hang in there. This covers the 2 days. I'll get you guys another video. Hopefully it helps. Talk to you soon.